Okay, so the last part of this 1 ton to 10 ton CO2 equivalent is actually us, people. Not every human being on the planet is the same when it comes to our carbon footprint, of course, as you can imagine. So this is on the carbon footprint of a Malawian average at 0.1 ton CO2 equivalent. I think Malawi is where Madonna adopted children from, and there is some very nice comedy about it that you can listen on YouTube. 3.3 ton CO2 equivalent per year for a Chinese person, 7 ton CO2 equivalent per year world average, 15 tons for a UK inhabitant, 28 tons for North American, and 30 tons for an average Australian. Okay, Australia, US, if you remember, along with Canada and Russia, have not been very prominent in signing on to Paris Agreement, even though things are changing now. But hopefully that'll remain so for the coming decades, where climate change is becoming a more and more serious issue already. So emissions per person and an estimate of footprint per person as done by this book. Fuel, pharmaceuticals, other medical instruments, electricity, transport, sewage and sanitary, and paper and card. Obviously this combination will be different for different countries, and this issue is generally quite complicated, especially when it comes to assigning blame to, let's say, population growth and climate change. People always say population is bad for climate change. In some ways this is true because we put a lot of pressure on resources, habitats, space for other species and resources for other species and so on. But if you focus on carbon footprint, then the story is usually not that simple. Okay, so let's look at some more data from Our World in Data, which I love. This site provides some very nice information for such courses. Carbon dioxide emissions from burning of fossil fuels for energy and cement production. Land use change is not included. So you can see that Mongolia shows up, but North America, Russia, the Middle East and Australia show up here, with China in the range now that is getting to be added up to the largest emitter in the world, as we know, in the last couple of decades. But one has to also consider where China's emissions actually come from. It is now the manufacturing hub for the world, which means it is producing a lot of things, manufacturing a lot of things, creating carbon emissions, but it is exporting embedded carbon to other places where these products are consumed. So how do you count for carbon emissions? Where the product is consumed or where it's produced? So this is always tricky as well. So CO2 emissions embedded in trade is plotted here. Share of carbon dioxide emissions embedded in trade measured as emissions exported or imported as the percentage of domestic production emissions. Positive values represent net importers of CO2. 20% would mean a country imported emissions equivalent to 20% of its domestic emissions. Negative values represent net exporters. So without worrying about the numbers, you see all these net exporters. Okay, there are some net importers. Surprisingly, Bangladesh and Nepal are here, and I think this is Singapore. No, that is probably, anyway, you can see what it is. Some there, is it Cambodia, Kampuchea, Laos, or one of those? So anyway, so many countries are producing things having a carbon emission that is high, but a lot of it is exported out in as embedded in products. That has to be considered. So you can also look at it as production versus consumption based CO2 emissions over time, 1990 to the present. So if you look at consumption-based CO2 versus production-based CO2. Obviously, consumption-based CO2 is higher, and it's not clear if the difference is increasing, but it could be, because US loves its air quality and water quality, and doesn't want to manufacture too many things, and in fact has tremendous problems dealing with issues of wages for laborers and labor unions and so on. So it prefers to manufacture things outside and bring them in. But if you look at a country like China, which wants to produce things and develop its economy, over time its production-based CO2 emissions have gone up tremendously, but with the economic growth also comes the increase in consumption-based CO2 emissions. So you can see that the difference has increased over time. So this is something one has to always remember. But you have to also remember the historical context for emissions and where we are now, especially because CO2 has a long lifetime, residence time in the atmosphere, a couple of centuries or longer, and it accumulates, and the warming is directly related to the accumulated carbon as well. So if you look historically, this is cumulative carbon dioxide emissions over the period from 1751 to 2017. Figures are based on production-based emissions, which measure CO2 produced domestically from fossil fuel combustion and cement, and do not correct for emissions embedded in the trade. So that's something you have to keep in mind. So North America has emitted 457 billion tons, or 29% of the global cumulative emissions till 2017. So that is Canada, Mexico and USA together. But EU and Russia and Ukraine, Turkey, etc. have had contributions as well. On the other hand, since 1990 or so, China has become a giant. Japan has always been part of the emissions since the World War II ended. India is growing, and the other countries here, and of course there are countries with smaller footprints, Oceania and so on, but they are also adding and increasing their addition as well. So the argument that have been made, arguments made and used under negotiations is that before 1990 or so, nobody was aware of the great danger of CO2 emissions from fossil fuels. Not necessarily true, because Svante Arrhenius, and even before that, I think Tyndall, Eunice Foote, Guy Callender, many articles were written about the increasing carbonic acid, carbon dioxide and warming potential and so on and so forth. Okay, so in this sense, cumulative carbon also would mean that population growth has to be considered in this context, per capita emissions, and when they started to emit. So if you look at cumulative CO2 emissions in this way by world region, obviously before Europe dominated everything, EU27 came in at some point, and they have been dropping over time. United States has dropped in its relative contribution to the cumulative CO2 because Asia, excluding China and India, and China, India, Africa, other countries have started adding more and more over time. So it's not that absolute emissions have reduced for Europe and EU and United States, but their relative contributions to cumulative CO2 have dropped because the total is now also being contributed to by these countries. So wealthy nations lead per capita emissions, as you can see. So this is countries with the highest per capita emissions in metric tons of CO2. The numbers here are different because it depends on what you are accounting for. Just fossil fuel and CO2 emission, consumption, production, and so on and so forth. Saudi Arabia and US are up here. Canada, Australia, South Korea, Japan, and China comes down here, and India is even further below. But even there things are complicated, because in China and India, with economic growth, there are rich people who are consuming probably at the European level, if not at the US level, which means the averages do not indicate the poor people who are consuming really little, and the rich 10% or so will be consuming a lot. This is a local representation of how the globe works, right? In the globe, richer countries are producing more per capita emission than poorer countries, but in poorer countries, richer people are emitting most of it, and so on. So the top 10% of the luxury consumption is contributing 90% of the emission, and the bottom 50% is contributing only about 10%, and so on. So there are various ways one can do these numbers, but it's better to accept that we are all in this together now, and everybody wants to grow economically and improve their standard of living, and quality of life is what is often sacrificed when you make a choice for, let's say, producing domestically to grow economically, but taking all the pollution with it, degrading water quality, air quality, health, productivity, morbidity, mortality, and so on. But how to get rich without increasing carbon footprint is still not very obvious, because all the rich countries have become rich with very high carbon intensity of life. So energy intensity of the GDP and carbon intensity of the energy have been high in all the rich countries, but unfortunately it's continuing along the same way for developing countries as well. So the world together has to find ways of lifting everybody to a high human development index, for example, without degrading the environment. So the ideas of circular economy and so on come in, but decarbonization is going to be the only thing that is going to really unify. Reducing emissions is not working so well. Despite the 25 years of negotiations, emission trajectories are still on business as usual. Renewables are increasing but not fast enough. Electric vehicles are increasing but not fast enough, and so on and so forth. Okay? Enough soapboxing, but I will leave it here.